Hello, everyone. My name is Martin, and today I would like to talk about GraphQL nullability. So I'm an engineer working on Apollo Kotlin, a type-safe client for Android and Kotlin multi-platform. And today I would like to make this presentation in two parts. So first, I'm going to introduce the problem, and then, obviously, we are going to take a look at solutions. And to introduce the problem, I'm going to take a very personal example. I'm going to take you way back to 2016, when I was an Android engineer at Dailymotion. Dailymotion is a video streaming company. It's an Android app. You can browse your videos. You can add videos to your favorites. You can obviously watch videos. Back at the time, the stack was mainly Java on the Android side of things and PHP on the backend. The PHP backend was a huge monolith. And whenever I think monolith, I have this image that comes to mind of the 2001 Space Odyssey movie, where the monolith is this big, magnificent thing, but it's also a bit intriguing. Like, we don't know really what's inside of the monolith. We don't really know who built it and for what purpose. So I was a bit like the monkeys in this picture. I was trying to poke at the monolith, sending GET requests. And with my other monkey colleagues, we figured out what could be returned from the monolith. So in that example, I was sending GET and got a JSON back with a bunch of properties about the videos. The video has an ID, has a title, a URL, upload date, maybe a view count, and a bunch of other properties. So what I did was model these JSON responses in my app and then do the parsing using something like JSON, for an example. So it was working, but a bit opaque as a process. Fast forward to 2017, the team at Dailymotion had the great idea to break down this monolith into a pattern that I think is well recognized today using microservices. So the monolith was still there. Like, there was still PHP in the backend, but as things evolved, they could take some of the functionality of the PHP monolith and move it to microservices, maybe in Python, maybe in JavaScript, maybe in Java, TypeScript, the language of preference. And this was all unified using a GraphQL API that the clients could then request and query. So be it iOS client, Android client, or of web clients. So this was really great because this gives us insight into what's inside the API. With tools like Explorer, we can have autocomplete, so I can know what is available in my backend. If I don't know what to type, like the tool can help me type. I have the full schema there with all the types, including nullability, like if something is not null, I have an exclamation mark. And I can even try in the tool and get a simple response from the backend. So it's very easy to iterate and experiment. 2017 was also a very exciting time to be an Android developer because it was the year Kotlin became the language of choice to build Android apps. So this is a picture at Google I/O, and I think every Android developer remembers this time because it meant that all the Java null pointers exception and so on were a thing of the past. Like a huge promise of Kotlin is to handle nullability and to get rid of that billion-dollar mistake that is null pointer references. And so when you look at it, like GraphQL on one hand comes with a full type system that handles nullability. And Kotlin on the other hand also comes with a type system, completely type safe, including nullability. So it was a perfect match, right? And they even share the same color. So it was really, they were really meant to be together. Except for one tiny little thing, is that in GraphQL, if you just use a string, like standard type, by default, it is non-null. But in GraphQL, by default, everything is nullable. So it's a bit weird, right? Like the logic is inverted. But I was like, it was my early GraphQL days, and I was like, well, It's not an issue. I can deal with that. I'm a qualified software engineer. I can do the mapping and remove the exclamation mark and add the question mark. Like, this sounds like something that's doable. So I started writing my queries. And first query, simple queries, I query a video, the title, description, view count, and a bunch of comments. Using Apollo Kotlin, I can get my query modeled in Kotlin into generated models. So I have a model for my video, and this video has Kotlin properties for title, description, and view count. So I can use autocomplete and everything that's available in Android Studio. So I'm doing this. I want to display a text with the title of the video. And well, there's something a bit weird here. Like, everything becomes red or underlined in red. And when I ask my IDE what's going wrong, my IDE says, well, you have a type mismatch. I wanted a non-null string, and you gave me something that could potentially be null. And I'm not happy about it, so I'm displaying red. And indeed, I went to the schema, and title is indeed nullable in the schema. Description as well, view count as well, comment as well. Everything was nullable. So I was like, this is weird, really, really weird. I was so excited about GraphQL and Kotlin playing nice together. Why do I have to handle null types everywhere? So I went to the backend open space and asked something like this question. Hey, everyone, why the hell is everything nullable in the schema? And everyone was like, we had this argument, like, should it be nullable? Should it not be nullable? And if everything is nullable, what is the point of having a type system in the first place? Because it's almost as if nullable doesn't exist if everything is nullable. And after a couple of hours, someone comes with this link to graphql.org. So it's a link to the official GraphQL website, the best practices, actually, that explain why everything is nullable in GraphQL by default. So I'm going to read this because this was a very important realization, and I finally understood why everything was nullable that day. So it says, most type systems which recognize null provide both the common type and the nullable version of that type, where by default types do not include null unless explicitly declared. So that's exactly what I was saying about Kotlin. This is the Kotlin version, like everything is non-null by default. However, in a GraphQL type system, everything is nullable by default. This is because there are many things that can go awry in a service backed by databases and other services. A database could go down, an asynchronous action could fail, an exception could be thrown, and so on. Beyond simple failures, authorization can often be granular, where individual fields within a request can have different authorization rules, and so on, and so on. So it makes sense, right? We live in a distributed world now. It's not anymore a monolith. It's a bunch of microservices, maybe in different data centers. And some of them might fail, and we don't want everything to fail. But on the other hand, it feels a bit disappointing that we cannot make the difference between what is null and what is an error. Like, to GraphQL, it's almost like everything is the same. But if you look in the details, it's not. We have two different things, like error nulls and semantic null. And an error null is displayed here. You still have null in title, but you also have an error in the errors array. And you can tell it's on title because of this pass here. Which brings me to, like, first important takeaway from this presentation. It's terminology. Like, in GraphQL, you have two kinds of nulls. You have the error nulls, which are exceptional, like something went really wrong. Maybe a microservice went down or a link was broken between the two data centers. These ones, they all have errors in the error array. But then, on the other hand, you have the semantic null, which are the normal null, which are part of your business logic. And these ones do not come with an error. So anyway, I went back to my code, and with everything I learned, I started to code. So first thing I was thinking about was do something like this. if you're showing this to a Kotlin developer, they're probably going to cry a little bit on the inside. This is really not recommended because it's going to crash at runtime. So I'm a qualified engineer, so I did something a bit better. And since I remember about error nulls, I'm just checking the errors. And if there is any error, I'm displaying error. And if not, well, I'm displaying the title of the video. And it works great. Everybody is happy. Application is released. People watch video. Everything is nice. Until 2 months later, I get graded in the morning with this nice Jira issue, priority highest, severity highest. Every time I try to open my video, the app crashes. What's going on? And this is very reproducible. Like I have an app, I go to my video, and I can reproduce the crash all the time. Well, someone did the root cause analysis and realized that we had a new feature called video upload. So you could now upload videos from your profile or your iOS or Android app. And during the upload, obviously, the video doesn't have a title. Or maybe even once the upload is finished, until you actually edit the metadata, there is no title. So what was before just an error null can now become a semantic null because it's now part of the business logic. Like null is a real business value for video title. But to the backend engineers, it was like perfectly fine. After all, the type was nullable from day one in the schema. So this was a backward compatible change. So what's the problem with this? So I had to change the Android app to include handling for this error. So instead of just always displaying the title, now I check for null. And if there is no title, I just display a placeholder. If we take a look at the different way I have to handle errors, I can either crash the app. Don't do this, it's not recommended. I can display a generic errors for the whole component. I mean, at least it's better. I can display null. Sometimes you see it in some website or in some apps. Like instead of displaying the title, I just display null. Not great. And finally, I can display everything all at once, which is obviously the best choices. But there is actually more. Like so far, I only talk about one field, but in a component, you might have several ones. Maybe you have the URL for the video, you also have the title, view count, and description. And let's say the view count changes very often because every time someone watches a video, it changes. So it's in a different microservice written in something else and using Redis or something else. Well, if that microservice fails, we want to be reliable and we don't want to crash. So we just want to ignore the view count and still be able to watch the video. So we need to handle partial data. And my UI logic becomes now something like this. If there is any error on the title, I cannot represent anything. So I just use a general error. But if there is a title that is null, I can use a placeholder. But if it's not null, I can use a title. But for view count, it's not the same thing. If there is an error, I need to skip the element. And if not, I need to display the view count. Well, you got me there. Like you saw where I was coming. If you have a lot of fields, it can get really fast. Like if you have 10 fields, you end up with more than 1,000 possibilities. And every time you have to discuss with your designer, maybe, what should we do with this element? Should we hide it? Should we display a placeholder? Is the error null different from the semantic null? If you need to handle these 3 different possibilities, then you end up with even more than 1,000 possibilities. So it's some kind of a guessing game. Like as soon as you see something nullable in the schema and you are a front-end developer, you have to guess. Is it a semantic null? Is it an error null? Is it maybe both? How do I handle that? Well, I don't know. And if I had to formalize that, I would say that the underlying issue is that GraphQL is missing some types. In your favorite type-safe language, you can have 4 possibilities to represent the different cases. But in GraphQL, you only have 2, whether it's an error null or a semantic null, or maybe a combination of both. It's all the same. It's all string here. Well, now that we've seen the problem, let's take a look at possible solutions. because there are some solutions. Solution number one is, of course, documentation. GraphQL comes with description. You can, for every field in your schema, set a description that says what the field is doing. And if the field is nullable, you can document, and please do it, under what circumstances a field might be null. This is the case for title here. It can be null if there is not a title yet, because the video was just uploaded. And if it cannot be null, you can also put that in the documentation. But this feels somewhat unsatisfying, right? The whole promise of GraphQL is we have a schema, we can have the machines do all these checks for us, and having to rely on documentation is kind of defeating the purpose. So what if instead we could evolve the language? GraphQL has been there for more than 10 years now, and the landscape has evolved. Like type-safe languages like TypeScript are a lot more frequent today than they were in 2012. So why not evolve the language? And turns out there is the perfect group for that. It's the GraphQL working group, and there are a lot of people working on that. So working group is an open source. It's an open group, really. Anyone can be part of the working group. You just go to the GitHub repository, go to the agendas, and edit it, make a pull request with what you want to talk about, and join the monthly meeting. And so a lot of people did this from the Yelp team in 2021, who were the first to initially recognize this problem. And they were using Apollo iOS CodeGen and had nullable fields everywhere. And they were like, we sure can do something better about this. And the idea was that the client could tell the server what it was ready to handle and what it was not ready to handle. So if it could handle a semantic null, it would say so. If it could handle an error null, it would say so. If it could not, it would also say so with an exclamation mark. But this goes as far because the client cannot really guess what the server intentions are. Like if something has a business reason to be null, this is a responsibility of the backend, not really the client. Fast forward to 2023, a sub-working group of the GraphQL working group was created to focus on that issue. And in September, GraphQL Conf happened, and this triggered a lot of brainstorming around nullability. If you have the opportunity, I definitely recommend you watch the talk from Stephen Spalding about nullability, which is a great introduction to what the problem is. And from there, a lot of propositions were made, like true nullability, asterisk, interrobang, semantic non-null, strict nullability, add catch, and so on and so on. So we have a few minutes left, so I'm definitely not going to be to go into the details of every one of them, but I'm going to talk about two that I think are representative. The first one is asterisk, and the second one is strict nullability. So remember, we said GraphQL is lacking some types. So why not simply add them? And for this specific type here that can never be a semantic null, so it can be an error or a strict, but never a semantic null, we could think of adding a star as a suffix, an asterisk. I love asterisk, so I could not resist the urge to put an asterisk there. And here we go. Now the schema can express more things. And the beauty of this proposal is that it does not change anything to the existing types. Like the existing GraphQL types do not change at all. We can also take another stance. And instead of saying the default should not change, we can change it and make the default non-null, or at least non-semantically null. But that means that the current everything is nullable or maybe an error becomes change with an interrogation mark. And in that case, we need to indicate in the schema somewhere that the meaning of this type change, or so maybe we need a global flag like strict nullability or something like this. So these are two examples of what could change in the GraphQL language. And with that, GraphQL types would match exactly your favorite TypeScript language, be it Kotlin, Swift, TypeScript, or maybe Rust or Haskell or anything else. Maybe not Java or JavaScript because they cannot really model nullability. So that was a lot. As a conclusion, maybe a few parting word is null is not always what it seems. So if you are a schema designer, always pay attention to the reason why you are making a field nullable, be aware of the trade-off, and most importantly, document nullability. This way, your front-end engineer gets a lot more context and information about the correct choices to make for error handling. And finally, get involved. There are a lot of discussion happening in the GraphQL community right now, and today is the best day to start building a better GraphQL for the years to come. So thank you very much, and thank you for watching. Bye-bye.